the right abrasive for abrasive blasting involves considering several factors to ensure optimal results and efficiency. Here are the key considerations. 1. Surface material and condition. The type of material being cleaned or prepared: metal, concrete, wood, etc. The condition of the surface: rusty, painted, oily, etc. 2. Desired finish. The finish required: smooth, rough, matte, bright, etc. The degree of cleanliness: light cleaning, heavy rust removal, surface preparation for coating, etc. 3. Abrasive properties. Hardness. Harder abrasives, like aluminum oxide, are more aggressive and suitable for tough materials, while softer abrasives, like plastic media, are suitable for delicate surfaces. Size. Larger particles create a rougher finish, while smaller particles produce a smoother finish. Shape. Angular particles, like crushed glass, cut faster and more aggressively, whereas round particles, like glass beads, are gentler and produce a smoother finish. Density. Denser abrasives, like steel shot, can clean more efficiently and last longer. 4. Abrasive type. Silica sand. Effective but can cause health issues, silicosis. Often replaced by safer alternatives. Aluminum oxide. Durable and effective for hard materials. Glass beads. Provide a smooth finish, ideal for polishing. Steel grit shot. Suitable for heavy-duty cleaning and peening. Plastic media. Gentle on delicate surfaces, often used for automotive and aerospace applications. Walnut shells, corn cob. Organic abrasives that are gentle and environmentally friendly, suitable for wood and softer metals. Garnet. Hard and durable, suitable for various applications including water jet cutting. 5. Environmental and safety considerations. Health hazards, dust, toxicity, etc. Environmental impact, biodegradability, recyclability. 6. Cost and availability. Cost effectiveness based on the project requirements. Local availability of the abrasive. By evaluating these factors, you can select the most appropriate abrasive for your specific blasting project.
Abrasive blasting. 6 questions to ask before choosing an abrasive. Question number 1. For this particular job, will the abrasive blasting be used for surface preparation or as a cleaning procedure? The difference between these two procedures is as follows. When abrasive blasting is used as a surface preparation technique, the intention is to both remove all the surface contaminants and also prepare the surface to receive a coating. When abrasive blasting is used to be as a cleaning procedure, then the intention is to remove only the surface contaminants while leaving the substrate untouched. Question number 2. Will it be possible to reclaim and recycle the abrasive, or will it have a single use only? The major deciding factor here is cost. The cost of abrasives varies widely, and some abrasive, while very effective, are uneconomical to use if recycling is not an option. Question number 3. Will the worksite be dust sensitive? The amount of dust generated by different abrasives varies widely. Some excellent type of abrasives are available are specifically graded to reduce dust. Question number 4. If blasting for surface preparation, what surface profile is required? All coatings have a recommended surface profile or roughnesses. Excess surface profile can shorten the life of thin film, low build coatings. Insufficient profile can cause delamination of high build coatings. Question number 5. Will the coating adhesion be affected by surface contamination? Some abrasives leave the clear surface than others, which can have a substantial impact on coating adhesion. Question number 6. Which abrasive provide the maximum productivity? Abrasive particle size, roughness, and shape all have an effect on blasting speed. Some factors to consider. The ideal abrasive size is where the largest particle is equal in size to the thickness of coatings to be removed. If the particle size is too large, the hit rate is reduced because the grain count in the pot is lowered. If the particle size is too small, the speed of cutting through the all surface is reduced. Grain roughness is a term given to describe its durability and
Ability. The tougher grain convert more energy in the removal of an old coating, while a weaker grain is more likely to disintegrate on contact. Particle shape can either be roughed or angular. Particle shape can either be rounded or angular. The more rounded the particle is, the more contact area it has, which increases the surface removal speed.